Welcome to Power Tech Simplified. In this video, we'll talk about one of the most important basics in electrical work: series circuits and parallel circuits. By the end of this lesson, you'll understand how they work, where they're used, and how they behave in real life. Let's begin. What is a circuit? First, a quick reminder. A circuit is a closed path that allows current to move from the source, through a load, and back to the source. How we connect the components changes how current and voltage behave. That's why it's important to understand the difference between series and parallel connections. Series circuit. Let's start with a series circuit. In a series connection, all components are linked one after another in a single path. That means the same current flows through every part of the circuit. The voltage, however, doesn't stay the same. It splits across the components. For example, if you have a 12-volt supply and two equal bulbs, each bulb gets around 6 volts. Another thing to remember is that total resistance increases in a series circuit. You simply add the values, and there's one big drawback. If any one component fails, the whole circuit stops working. This is why old decorative lights used to go off completely when one bulb burned out. Series circuits are used in battery packs, protection devices like fuses, and some simple indicators. Now let's look at parallel circuits. A parallel connection gives every component its own path straight from the supply. In this case, voltage stays the same across all branches. Each load gets the full supply voltage. Current divides. The branch with lower resistance gets more current, and the one with higher resistance gets less. Total resistance comes down when you add more branches. One of the biggest advantages is that if one load fails, the others keep running. This is why almost all home wiring is done in parallel. You'll see parallel circuits everywhere: in houses, distribution panels, appliances, and lighting systems. Let's compare both. Series circuits have only one path. Current stays the same, voltage divides, and resistance increases. If one device fails, everything stops. Parallel circuits have multiple paths. Voltage stays the same, current divides, and total resistance decreases. If one device fails, the others keep working. A simple rule to remember is this: series increases resistance. Parallel decreases resistance. Imagine 3 bulbs. In series, all bulbs glow dim. One bulb goes off, and the whole line shuts down. In parallel, each bulb glows bright because each branch gets full voltage. And if one bulb fails, the rest stay on. This is exactly why our homes use parallel wiring. That's the basic difference between series and parallel circuits.